Hello everyone, this is Vani from R.M.K College of Engineering and Technology. In this video, we are going to learn about digital modulation, which is the topic in digital communication. So, why first modulation is needed? Digital modulation is needed. We need to understand that. So, normally, without modulation, what we call it as baseband pulse transmission, the input data represented are in the form of line codes, right? And the baseband signals have large power at low frequencies. So normally we prefer to transmit the baseband signals over a pair of coaxial or pair of wires or coaxial cables. But it is not possible to transmit the baseband signal over radio links or satellite, that is over long distance communication, because we need large antennas which are not practically possible. Hence, the spectrum of message signal has to be shifted to higher frequencies in order to reduce the antenna size. So this is achieved by using baseband digital signal to modulate a sinusoidal carrier, right? So this is called digital carrier modulation or digital passband communication. So the need comes here where for long distance communication we cannot use baseband signal as such. So we use them to modulate the carrier, and then we transmit over long distance by using satellite or radio links. So in this video, our objective is to just know about what is digital modulation techniques, types we will understand. Then we will just see a fundamental passband model and design goals of digital modulation scheme. So, in general, the digital modulation are having two categories. One is coherent technique, another one is non-coherent technique. In coherent, the local oscillator generated at the receiver is phase locked with the carrier at the transmitter. The meaning is whatever carrier is generated at the transmitter, the same has to be used at the receiver. Hence, it is called as synchronous detection. So, we use phase locking for this. Whereas non-coherent technique is in which the detection process does not need receiver carrier to be phase locked with the transmitted carrier. So from this definition itself, it is very clear that non-coherent technique becomes very simple because no need to phase lock the carrier frequency. At the same time, the error probability increases. The performance is inferior compared to coherent technique. So it is up to the user who selects between coherent and non-coherent. If simplicity is needed, we go for non-coherent, but we cannot compromise with the error, then we will go for coherent technique. So in general, classification of digital modulation schemes are binary schemes where we use only two bits, either 0 or 1. In M-array scheme, we can send any possible M number of signals, right? So just two possible signals if we are sending, then it is called as binary, where the types are amplitude shift keying, frequency shift keying, and phase shift keying. And in case of M array, we can send any one of M possible signals, and the examples are M array PSK, M array FSK, QPSK, MSK, QASK, or QAM, and so on. M-array schemes need less bandwidth as compared to binary schemes, but the error performance of M-array scheme is poor as compared to the binary schemes. So let us understand a fundamental model. In transmission and reception of a digital carrier signal, we use modulator at the transmitter and demodulator at the receiver, and both these devices combined together, we call it as modem, which we use for our Wi-Fi communication. So the digital modulation formats, as mentioned, either they can be binary data or M-array data. And for the carrier, we are using sinusoidal signal. And how we are differentiating with the sinusoidal carrier, the feature that is used by the modulator to distinguish one signal from the another, it may be in the form of amplitude or frequency or phase. which is turning out to be, if we use amplitude, we call it as amplitude shift key. If we use frequency, we call it FSK. If we use phase, we call it phase shift key. And PSK and FSK signals are much more widely used than ASK signal because of the noise immunity of PSK and FSK schemes compared to ASK. So some of the useful terms which are required in understanding the digital modulation are probability of error. The most important goal of passband data transmission system is to design the receiver having minimum value of average probability of error, and PE should be as small as possible. And the power spectra is again one of the important parameter, which is a graph of power spectral density plotted on y-axis versus frequency on x-axis. It gives the information about the bandwidth requirement and co-channel interference. So that's also very important. And bandwidth efficiency, where the ratio of data rate, that is RB, to the effectively utilized channel bandwidth, B, is termed as bandwidth efficiency. And the communication should be spectrally efficient, right? So these are the useful terms. Whenever we learn each type of modulation schemes, we will understand, we will discuss in terms of these parameters. So a fundamental passband transmission model, I told you earlier that without modulation, the signal is called as baseband. And for long distance communication, we incorporate modulator. So if we see here, the source is generating the message, it is encoded, modulated. For modulating, it needs carrier signal. So that is given by carrier oscillator. And after modulation, the signal is sent over communication channel. So this part is transmitter and this part is a receiver, where we have demodulator. As I told you, in case of coherent, we will again use the same carrier oscillator here in order to detect the signal in synchronous manner. And finally, the signal is detected and estimated. This is just a fundamental transmission model in order to understand where modulation and demodulation play roles. So, in order to understand digital modulation schemes, because as I told, there are n number of methods available. Either you go for M-array or a scheme, or you go for binary scheme. We have so many methods. So, out of that method, in order to select a particular modulation schemes, we have to keep in mind that the data rate should be maximum, probability of error should be minimum, the transmitted power, costliest commodity, should be minimum. The bandwidth should be effectively used, that should be minimum. And the signal should have resistance to the interference, and the circuit complexity should be minimum. So any digital communication method or model will be selected for communication based on these parameters. So these goals are very important to be remembered for designing digital modulation scheme. Thank you.